Oh, we are live now. Okay, good morning, grade fives. Uh, I'm Maluleke, as you know, and then I'm going to be taking you through formats. Okay, I hope most of you have been able to join. And then I've been having some questions from the learners, and they're asking if we are going to go back to Zoom. So let me answer you. For those that did not hear my answer, so we have moved to Teams due to security reasons. So Zoom had some security issues, and then to protect you guys, the school decided to go to transfer to Teams so that we are able to protect your data and everything. So this is for your own security. And then what happens with Teams, so what we usually did on Zoom, you guys will be unmuted. So that feature is not there, it's not yet there on Teams, but I'm sure Microsoft is working on it so that in the coming days, you guys will be able to be unmuted and you can talk. Okay, and then yeah, so that is about Teams. And then there is a link that you guys have to join the same way that we did on Zoom. So every day a link will be posted. I assume since you guys are here, your parents know how to do the link, and maybe some of you also know how to do the link. That's why you were able to join. So yeah, so we are now on Teams, and that is the platform that you're going to use. If there's any changes, if there are any changes, you guys will be notified. Okay, so before I get on to today's lesson, okay, I've seen from the chats that I had, some of you, most of you were here yesterday, and I don't know who else is the new one who's joining. So I'd love to do a recap of yesterday's lesson so that so that we can be on the same page. So yesterday we were doing addition and subtraction of fractions. And then we looked at the rules that we have to follow when we're doing addition and subtraction of fractions. And then one thing that actually popped up was when we do addition and subtraction of fractions, we actually have to add only the numerators if the denominators are the same. So now in grade 5, according to CAPS, you guys are doing denominators that are the same, so you're not adding denominators that are different. So you're only going to start adding different denominators in term 3, and then another skill will be added there. So for now in term 2, and also for your, okay, I don't know if there's going to be June exams, but for your June exams, you'll see that you only have to add the denominators that are the same. And we say that you only add the numerators. So that's what we did yesterday. And then we also looked at subtraction. And what I also liked yesterday, there was interaction between me and you guys, and then where I asked questions, people were answering, and then I would like us to do that also today, because that is the only way for me to see that you actually understood what I taught. And then if you have any questions, I'll be able to see them on the Q&A. So that is the way that you use to communicate. There is a Q&A, it's live. So when you post a question, I will see it. And then if it's a question that I see that other learners should see it also so that they can see the answer that I get, I'm going to publish it. So all your questions, I see them, and then I'll also answer them verbally because typing for me will take time because I can't type and teach at the same time. So I will call out your name and say, okay, so praise, you asked this, and the answer is this, and then you're going to be answered. I will type also if I have time, but mostly I'll do it verbally. So if you ask a question, I'll call out your name, and then I'll answer your question. All right, so coming to today's lesson, we are still doing fractions, and I said, someone asked yesterday, I don't remember whether it was Gia, I don't remember who, and they asked, ma'am, are we still going to do fractions? So today is the second from the last day of us finishing fractions. So today I said we are going to convert improper fraction to a mixed number and vice versa. And then tomorrow someone also asked, ma'am, are we going to do the division of fractions? And I said it's called fraction of a wall. That's what you're going to do tomorrow, and problem solving. And then we'll be done with fractions. And then on Friday, I said we're going to start on length, and I can't wait to start on length. I'm sure you also can't wait. All right, so let's not get ahead of ourselves and talk about today. So we are the topic is converting fractions. And then by the end of the lesson, you'll be able to convert improper fractions to a mixed number. And you're also going to be able to convert from a mixed number to an improper fraction. So that is what we are going to do today. Okay, just checking if we have any. Okay, now, so I have to. Oh, I see Lutando. Lutando is excited to be doing fractions. Oh, yes, length on Friday. Amanda, yes, you have to be here for that. All right, so now that we have looked at what you guys will achieve by the end of the lesson, let's start the lesson. Okay, this one is an interesting one, and once you get it, because you're also going to do it in your senior phase. I always say, you guys remember, okay, we are past foundation phase and you're in the intermediate phase. So whatever that you get right now, your maths years are going to be very easy. Okay, so especially for those that were not here, for some of you, I know by now you are singing these definitions because I know that you guys really pay attention. Okay, let's look at the definitions of these fractions. So we have 3 different types of fractions that you have to know. And so all these, they fall under the umbrella term or the category of common fractions. So we have mixed fractions. And what is a mixed fraction, you will ask? So a mixed fraction, these are fractions that consist of a whole number and a fraction. So a whole number, we say it's a full number, and then a fraction is a part of a whole number. So in simpler terms, if I talk about a whole number, I'm talking about that orange that is not peeled yet. So if it's an orange and it still have its peels, that's a whole orange. But the minute you take your knife and then you cut your orange into 4 and you take one piece, then we say that is a part of a whole. So then we call it a fraction. So a fraction is a part of a whole, and then a whole is a full, it's untouched. So a mixed fraction consists of a whole and a fraction. And then we also have what you call an improper fraction. And then improper fractions, these are fractions that have a numerator that is bigger than the denominator. For example, okay, so an example of a mixed number is 3 2/3. And then the example of an improper fraction is 19/6. So if we can look there on that fraction, we have 19 here, which is the numerator, and then we have 6, which is the denominator. So this, we call it an improper fraction. And this is not the first time that we've spoken about an improper fraction. And I also named it, and we said that if you maybe have forgotten what an improper fraction is, we can also call it an abuse fraction because the bigger number is on top of the smaller number. And then the last fraction that we have is proper fractions. So these are our normal everyday fractions. These are your halves, your 2/4, your 1/3, your 1/10. So those are the proper fractions. So these fractions have a numerator that is smaller than a denominator. For example, 2/4. So we can see here, for example, 2/4. And then we say that the value of an improper fraction is always more than 1. And today you're going to see why I always say that. And then we say the value of a proper fraction is less than 1. And then a mixed number obviously is more than 1 because it has a whole and a fraction. So those are our definitions. And then looking at changing from mixed number to improper fraction. So before we can look at adding and subtracting mixed numbers, we have to look at how we can convert from mixed numbers to proper fractions, to improper fractions, and vice versa. So a mixed number, as we have said, have a whole number and a fraction. So this means that it can also be converted to an improper fraction. So let's first look at the practical conversion before we move to abstract one. So abstract, let me explain what abstract means. I said So in grade 3, grade 2, grade 1, every time we have to add, our teacher will either give us dough or will give us counters, or they'll give us sticks. Sometimes they'll give us marbles. And then after that, we move and then we represent it in a diagram. And then abstract, that's when you do not need any diagram. You do it off your, we use rules, and then there's routines. So before we can move on to that, we always start from here. All right, so you see, diagrams make it easier for us to see what we're talking about, because if we can see it, then it's going to be easier for us to do it. So converting from mixed number to improper fraction. So you guys are going to do this one for me. See, I didn't write any answers because I want you guys to participate. So here we have how many whole numbers. So how do we see a fraction, I mean a diagram that is a whole number? We say that a diagram that is a whole number, it has all the parts shaded. So how many parts are shaded here? We have 1, 2 full circles that are shaded. And then we also spoke yesterday about we check how many, for us to get the denominator, we check how many parts is the whole divided into. So in this case, on the first diagram here, we can see that the whole is divided into 3 parts. So these 3 parts becomes our denominator. And then how many full circles do we have? We have 1, 2 circles, 2 full circles. So these are oranges that are not cut yet. So 2 full, and then it's 2 holes. So you're going to write it like this. You say 2 holes, and then we check on the one that is not full, and we check how many is shaded. So 1 is shaded. So then we'll say we have 2 holes and then 1/3. So this is writing it in a mixed number form. And then when we come to in the improper fraction, we still have the same circles or the same fractions shaded. And then we ask, how do we get the improper fraction? We ask how many parts are shaded all together. So instead of counting it in wholes, we count how many parts are shaded all together. So we come here and then we check. We have to count the parts that are shaded. So it's 1, 2, 3, 4, 5, 6, 7. And then always in an improper fraction, the shaded part makes the numerator, and then the denominator does not change. Still, the denominator is how many pieces is the whole divided into. So you just check one circle. Even if you have 20 circles, you check into how many is it divided into, and then we see here our circles are divided into 3. So the numerator is then the shaded part, and the denominator is into how many equal pieces has the whole be divided into. So then what I want you guys to do, so then how do we write it in an improper or as an improper fraction? How do we write it? So I'm going to wait for you there. Okay, I saw yesterday, if you say over whatever, it's fine. Or some of you knows how to use the fraction line, it's also fine. So what I want you to write for me now, we've written the first sum here as a mixed number, and we say it is 2 1/3. And then for us to write it in an improper fraction, I said we count how many parts are shaded, and then that is our numerator. And then to get our denominator, we check into how many parts is the whole divided into. So how do we write it as an improper fraction? So I'm going to check here and see. Okay. Okay, people greeting here. Okay, Ria greeting. Okay. Okay, Amanda, I hope you got time to copy it. Yes, okay, praise, I see. Okay, thank you for the definition. Okay, praise gave us there. Okay, Ashlyn, I see. Okay, I'll talk slower. Okay, Lutando, I see you saying you loving fractions. Okay, very interesting. Thank you. All right. Okay, I was just checking the charts that you guys remember. I can't see the chart as I'm explaining, so I'm just going over the charts. Okay, so let me repeat what I said because I see. Okay, Naledi, it's the other way around. Okay, Corner, you are right. Well done. Amanda, you are right. Okay, Uradile, you are right. Praise, check your answer for me. I hope you guys are still able to see. I'm sure you can see the fractions because I can't see now. I went to the chart. Uradile Nkele, you are right. Okay, still waiting. Okay, Butle, you are right. Okay, Butle is right. Okay, Amanda. Okay, Connor, are you doing the next one now? Oh, okay. All right, Amanda. All right. Okay. So I've read your answers. Okay, here. So this is okay. The ones that got it right, well done. So here, the way that you write, remember an improper fraction, if you say 3/7, it is no longer an improper fraction. And then we said we get the numerator by counting, okay, whether it's an improper fraction or a proper fraction, we get the numerator by counting how many parts are shaded. So here we count how many parts are shaded. We said there are 7. And then how do we get the denominator? So the denominator, we just have to check on one whole into how many parts is it divided into. So it means there the answer is going to be 7/3. Let me give you a tip. If you see that you say 3/7, it is not right because it is no longer an improper fraction. As Praise typed for us there, that an improper fraction, the denominator is smaller and the numerator is bigger. Okay, and I see Lutando is having a time of her life. All right, and then let's look at the second one. I don't give one example and then think that people have understood. No, I don't do that. I accommodate everyone. Okay, so on the second one, we have 2 holes there, but how many? Okay, now I didn't give you the mixed number, but I gave you the improper fraction. So as a mixed number, how many holes do we have? Before we can check how many holes do we have, full holes, the one that I shaded, the whole circle that is shaded. Before we can check that, we have to determine our numerator. And then how do we get our numerator? We check into how many pieces is the whole divided into. So if we check here, our whole is divided into 1, 2, 3, 4, 5 pieces. So even here, our whole is divided into 5 pieces. So this means that our denominator is going to be 5. So irregardless of how many holes we have, our denominator is going to be 5. And then how many whole numbers do we have? How many full circles do we have that are fully shaded? We have 1 and 1 and now I want you to tell me it's 1 and so what will be the fraction? What is going to be the fraction? I've already told you that the denominator is 5 and then the whole number is 1 and what is the fraction? I'm going to go and check what your answers are. Okay, I see. Oh, okay. Okay, people were answering there. Okay, for us maybe not to be confused on the answers, now we are doing the second one. I see Connie is excited and answering, I think it's the third one. Now we're answering the second one. Okay, Odelia, you were right for 7/3. And then Naledi, you were right. Okay, Zara. Okay, so Platinum, on this one, you're asking about which page it is. Okay, so on this one, unfortunately, Platinum does not touch much on it. So I relied mostly on my internet sources. That's why I put more examples so that you know it. So Platinum did not dwell much on it. So we were short there, Zara. So you just have to listen to what we are saying and then also copy the numbers. So this is the knowledge that you have to know. Ne? Okay, I see Audrey is still okay. You got right. Praise, yes. Yes, Lutando, I can see your charts. I can see your charts, Lutando. I can read your answers. That's why when I say Grace got that one right, yes. Amanda, you saying yes because you got it right. I see all your charts. Okay, Naledi, all right, I said now it's a mixed number, is a mixed number, is a mixed number. Audrey, okay, we're not on as a mixed number. Okay, one whole. Yes, Amanda, you write one whole, and then I want the fraction part. I want the fraction part. 8/5. Okay, Uratile Nkele, you got it right. Let me just read Uratile's answer. So Uratile said it's 1/3/5. So you are right, Uratile. Amanda, yes, you are right. 1/3/5. Morning, Neo, and you also right. Neo, you were late today. Okay, I didn't see in the chat. Okay. Yes, 1/3/5. You are right. Yes, praise 1/3/5. Okay, praise. Okay, all right. I see you corrected that one. Yes, Naledi, you are right. 1/3/5. Okay, as an improper fraction now. Oh, okay, yes. Okay, anonymous. I don't know your name there. Okay, Gia. Just check for me that one. Okay, Grace, are you now writing it as an improper fraction? Okay, thank you. Okay, Zeketelo, the answer is 1/3/5. Sedi, okay, Ashlyn, just check your answers for me. Yes, Praise, you were right. You were right. 1/3/5, you were right, Praise. Amanda is so okay. Amanda makes me laugh. I can imagine you in class with a yes. Okay, I can just imagine your character. Okay, Audrey, you had the right answer that time. Yes, Audrey, that one, 1/3/5. Okay. One year is Zeketelo. Well done. Well done, Zeke. Okay, I see Audrey. All right. Okay, thank you guys for yes, Ria. 1/3/5. You are right. Where is Lutando with the answer? I told you I can see your answers, ne Lutando? All right. So the second one here, it's one whole because one full circle is shaded. And then our fraction on the mixed number part, our fraction is 3 because 3 is shaded. Remember, 3 becomes our numerator, and then 5 because it's divided into 5 becomes our denominator. And then I gave you the answer on the improper fraction. So how many parts are shaded? 8 parts are shaded, and then the whole is divided into 5. So we're going to write it as 8/5. And then let's look at the last one before we move on to the next one. How many, as a mixed number now, how many holes are shaded? How many holes are fully shaded? So the holes that are fully shaded here, it's 1, 2, 3 holes that are fully shaded. And then let's look, how do we get our denominator? We just look at one hole and then we check into how many pieces is it divided into. So it's divided into 1, 2, 3, 4, 5, 6, 7, 8. So the cutting is cut into 8. So that becomes our denominator, our bottom number. So a denominator is the bottom number. It becomes our denominator. So then we're going to say our answer here as a mixed number. It's 1, 2, 3 holes. And how many is shaded? Now we want the fraction. 1, 2, 3 is shaded over 8. So the answer is 3 holes and 3/8. And then as an improper fraction, we come here as an improper fraction. How many parts are shaded? So we said 8 is fully shaded there, so we'll say 8, 16, 24, and then 25, 26, 27. So that is 27. And then how do we get the denominator? So the denominator is into how many parts is the whole divided into, and this whole is divided into 8. So then our answer as an improper fraction is 27/8. So that is how we change from a mixed number to an improper fraction, grade 5. Okay, Ashlyn, I hope you are with us. Okay, so now let's convert from mixed number to an improper fraction. without a diagram. Now that's where the abstract part comes in. So a whole number that we have here is 2 and 1 over 3. So you get it now in an assessment. You don't have a diagram, you don't have time to draw the diagram, or you don't even have the instruments to draw the diagram with. So what is it that you do? So I have two methods for you. You use any one. Okay, I want you to listen here. Very important. Okay, so let's look at the sum. Is 2 wholes and 1 over 3. So what does this mean? This means that the 2 wholes here, remember we said, so we look at the denominator. Our denominator is 3, and then we ask ourselves, if we have a whole and it's a fraction, how do we write it if our denominator is 3? So we ask ourselves, if we have a whole and that whole, instead of writing 1 whole, how are we going to write 1 whole as a fraction? So 1 whole as a fraction, and if our denominator is 3, it means that 1 whole as a fraction is going to be 3 over 3. And then we come here, how many 3 over 3s should we have? Because we have 2 and 1 over 3. So this means that we must have 2 wholes. So then those 2 will be 3 over 3 plus 3 over 3. 3 over 3 makes 1 whole, right? Grade 5, we agree 3 over 3 makes 1 whole, right? But how many wholes do we have? We have 2 wholes. So 3 over 3 makes 1 whole, and we want 2 wholes. So then we'll say 3 over 3, and then we plus another 3 over 3. And then remember yesterday we did addition of fractions. And then now that we are done with the wholes, then we come on the fraction. How much do we have? We have 1 over 3. So this is 1 whole, which is 3 over 3. And this is the second whole, which is 3 over 3 again. We are adding now. And then we also add this fraction, which is 1 over 3. So how do we add? We said yesterday that we do not add the denominators. We only add the numerators. So the numerators is 3 plus 3, which is 6, plus 1, which is 7. So our answer is, so the denominator remains the same. Our answer here is 7 over 3. So that is the first way of doing it. That is the first way of doing it. Or you can do it like this. So first way is just for you to break down these 2 wholes. So if we had 2 and 1/4, it means that your whole was going to be 4 over 4 plus 4 over 4. And then if we're 2 and 1/5, your whole was going to be 5 over 5 and plus 5 over 5. So the denominator tells you what your whole is. I hope you understand, but there's an activity that we'll do together. Okay, once you can understand this method, there is a second method that you can do. But this one, you must not forget what you multiply and what you add. So another second method of doing it, this is the second strategy. You can take the whole and multiply the denominator. The answer that you get, you add to the numerator. I'll repeat. You can take the whole, and our whole is 2. You multiply with the denominator, and the denominator is 3. So you say 2 multiplied by 3, and then you get 6. And then the answer that you get, you say 6 plus 1, which is the numerator, and then you're going to get 7. You're going to get 7 over 3. So, okay, I also explained it here. So what this means is that you multiply the whole number with the denominator. So you say 2 multiplied by 3, and then you get 6. And then the answer that you get, you add the numerator, you add to the numerator, then you say 6 plus 1 equals to 7 over 3. The denominator does not change. So you say 7 over 3. So that is another way of converting from mixed fraction to an improper fraction. I'm going to stop here, and then I'm going to go to the chat, because I know maybe some of you okay, the chats are blowing away. Okay, they're answering for that. Okay, I see people. Okay, we're answering for that. Amanda, what is XDD? I don't know. You know, I wasn't born. Okay. I wasn't born through technology. I was born before technology. Okay, I think people were answering for that one. Okay. 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 All right. Oh, I'm just checking your chats. Kumuzo. Okay, hi, ma'am. Sorry, I'm late. Okay, ma'am, you are too fast. Okay, Kumuzo, I don't think I'm too fast. It's because you were late. But I will repeat again what I said on the other example. You arrived 24 past. It's fine. Uh, I think you couldn't catch up with us because we started already 20 minutes uh, later. Mama, my father also thought. Okay, all right. Okay, all right. I see. Okay, I'm checking improper fraction. Okay. Okay. All right. So I'm just checking your chats because remember I said when I'm teaching, I can't. Okay. When I'm teaching, I can't see the chats. All right. All right. So Kumuzo and Audrey also, let me repeat what I said. I said we can also convert from mixed number to an improper fraction without using without using diagrams. So, and then I gave you an example. So the example here is 2 and 1/3, and we want to convert it from a mixed number to an improper fraction. And then I said the first method that we can use, we can split these two wholes, we turn it into a fraction. How do we do that? We look at the denominator, and the denominator is 3. So this means that the two wholes must be 3/3 and another 3/3. And then we say 3/3 equals to 1 whole. But then on here we see we have 2 wholes. So which means we must have how many? We must have 2 3/3s. So we have 3/3 and then we have 3/3, and now we have our 2 wholes as a fraction. And then we then add also this 1/3. So then we'll say 3/3 plus 3/3 plus 1/3. And then yesterday, maybe Kumutsu, you were not here, but thank you for joining us tomorrow. I know you're going to be early. So now we said yesterday when we add, because now we have to add these fractions, we only add the top part. So we only add the numerators. Then we're going to say 3 plus 3, which gives us 6, plus 1, it gives us 7/3. And then thereafter, this is the second method that you can use. So the second method that you can use, you can take the whole number, which is 2, and then multiply it with the denominator, which is 3. So we say 2 multiplied by 3, and then we get 6. The answer that we get, we have to add to the numerator. So it's a times down, and then going up, it's a plus. So we times down, we plus up. 2 times 3, 6, we plus up, 6 plus 1 is 7. And we always start with the times, and then the answer that you get on the times, we add it to the numerator. And then we'll say the answer is 7/3. So that is what I was explaining, Kumuzo. And then now the second example, we are changing from the mixed number to an improper fraction. So it's still the same thing. We're still changing from a mixed number to an improper fraction. So the mixed number that I gave you there is 3 and 2/5. So how many wholes do we have, grade 5s? We have 3 wholes. And then if we write those wholes as a fraction, we have to check the denominator, and then our denominator is 5. So it means that one whole is 5/5. And then another, how many 5/5 should we have? Because we have 3 wholes, it means that we must have 3 5/5s. So here we have it. So we have 5/5, and then another 5/5, and then another 5/5. So 5/5 equals to 1 whole. And how do you know? Ma'am, how do I know I should write 5/5? I said you must look at the denominator. So the denominator determines what we write our whole as. So because our denominator is 5, so you write 5/5 plus another 5/5 and another 5/5 because we have 3 wholes. And then after that, You say 5 over 5 plus 5 over 5 plus 5 over 5. We have taken care of these three wholes. And then the fraction, we have 2 over 5. We also have to add it on here. So now we have 5 plus 5, which gives us 10. And then 10 plus 5, it gives us 15. And then 15 plus 2, it gives us 17. So 17 becomes our numerator. And then 5 doesn't change. It becomes our denominator. Now, this is an improper fraction. So we have changed from a mixed number to an improper fraction. So that is the first method that I said you can use. But then because I'm not stingy, I also gave you the second method. So the second method is that one where you have to multiply. So I said bottom, we multiply. The answer that we get, we add to the numerator. So if I multiply the bottom, I'm going to say 3 times 5 equals to 15. And then 15 plus 2 equals to 17. And then our denominator does not change. So then method 2 is a shortcut, but you just have to understand that this is 3 wholes and then our denominator is 5. So this is a shortcut, and this long cut makes you understand that our whole is made out of 5 over 5. So it is, I would advise you to use both the methods so that you are able to see that indeed your answer agrees, because on both the methods, your answer should agree. As you can see, it agrees with me here. So you use whichever method you understand best. After you have explored those methods, then you use the one that you understand the best, and your teacher is going to mark things right for you. Amanda, yes, because I'm not stingy with the strategies. Okay, thank you so much for the compliments. All right. Amanda, okay. Let me leave Amanda alone. Amanda is being naughty on the chats. Okay, I've moved away from the chats because Amanda is distracting me. Ne, Amanda, yes, because I'm not stingy. All right. So here, I'll just project it and then you guys can do it on your own. So if you can go to YouTube, you'll see the same lesson. So this one, because this work is not there on the platinum, this is an activity that I'm giving you. So I'm projecting it so that when you scroll, you can find it. Okay. All right. So now let's look at, okay, converting from improper. Remember, we're converting from mixed number to an improper fraction. So this one is the easiest. Converting, yes, I'm not stingy, Amanda. Converting from improper to mixed number. So with changing from an improper fraction to mixed number, you have to remember that the line, that division line, it's that the line that separates the numerator and the denominator is actually a division line. So for example, okay, the question is convert 13 over 5 to a mixed number. So this is the same as saying 13 divided by 5. Simple. Yes, it's as simple as that. So this is the same as saying 13 divided by 5. And then what is 13 divided by 5? Remember, divided by 5 means that you count in fives. So if I count in fives, I'm going to say 5, 10. I can't say 15 because 13 is before 15. So if I say 5, 10, I get 2, and then 2 remainder, 3. But we do not write it as 2 remainder 3 because we are doing fractions. So this 2 becomes our 2 wholes, and then the 3, we write it as 3 over 5. Where do you get the 5 from? You get the 5 from here. It was 13 over 5, so our denominator doesn't change. So it's 2 wholes and 3 over 5. So that is how we, okay, this one is easier. And then example 2, still converting from that abuse fraction, improper fraction. So the minute you see an improper fraction, read it as 28 divided by 10. It's 28 over 10, which is the same as saying 28 divided by 10. To a mixed number, then we can say, you can either say 28 divided by 10, or you can say how many 10s are there in 28. So this simple means that I have to count in 10s, but I should not pass 28. So if I count in tens, I'm going to say 10, 20, and that's 2. And what is the remainder? To move from 20 to 8 to 28, the remainder is 8. But we do not write it as 2 remainder 8. We have to write it as 2 and 8 over 10. So we write it as 2 and 8 over 10. Okay, another one, convert 33 over 5 to a mixed number. This is the same as saying 33 divided by 5. And then you say, how many times does 5 go into 33? What this simple means is you have to count in fives until you reach a number that is closer to 33. So we count in fives. We're going to say 5, 10, 15, 20, 25, 30, and that's what? That's 6. And then from 30 to go, I can't say 35. You see, because I would have passed 33. So I'll say 5, 10, 15, 20, 25, 30, that's 6. And to move from 30 to 33, it's how many? It's 3, so that is the remainder. But we're not going to write it as 6 remainder 3. We have to write it as, it's here. We write it as 6 and 3 over 6. So that is how we write it. I think, oh, okay, nice. Now it's your time. Okay, we're going to eat some. Okay, we're supposed to end at 11:45, but we'll take some few minutes. Okay, so the question is, convert from mixed number to an improper fraction. Here is the mixed number. I'm going to go to the chart, convert 2.5 from a mixed number to an improper fraction. Okay, Kia, you are saying the one of multiplying is kind of hard. Okay, remember I gave you 2 ones because I'm not stingy. So use the one that you understand best. Okay, so the question that we have is convert. Amanda kills me. Okay. Thank you, Zeketelo. You're also the best. Kia, you love things. Okay, all right. So the question is, praise you doing length after fractions. The question is convert 2.5 to, did my voice went low? Oh, okay. I hope you can hear me now, praise. All right, convert 2.5 to an improper fraction. 2.5 to as an improper fraction. So remember, if it's 2.5, how many wholes do we have? We have 2 wholes. You missed it by 1 praise. You didn't add the half. Okay, didn't add the half. 4 over, praise. 4 over 4. Okay, I think I have to explain this one. So it's 2.5, right? And then yes, Connor, you are right. That answer is perfect. Well done. You can clap hands for yourself. So 2.5, our denominator is 2. So meaning that you're going to have 2 over 2 plus 2 over 2 plus 1 over 2. Kia, you said that one is a little bit harder. Let's use this one. It's 2.5. So you're going to have the half. Our denominator is 2, right? So you'll have 2 over 2, which is the first whole. We have 2 wholes. So it's 2 over 2 plus 2 over 2 plus 1 over 2. So I see Con, okay? Okay, Connor got it right. Okay, praise, the 5 is right, but the 4, remember, we do not add the denominators. Okay, Grace, you didn't add another whole. Yeah, praise, let's that one, correct it. Yes, Naledi, 5 over 2, you are right. Naledi, you are right, 5 over 2. So it's here, it's 2 wholes. So which means that our whole is made of 2, right? So we'll say 2 over 2 plus 1 over 2, and then the answer is 5 over 2. Second method, if you want to use the second method, you can say this whole multiplied by the denominator. So you say 2 plus 2 equals to 4, and then you say plus 1, which is 5 over 2. So the answer there is 5 over 2. Let's do number B. Is 10 and 3 over 10. So you see, if you see that the whole is bigger, oh, no, go back. If you see that the whole is bigger, then you can use the second method. So the second method says we must multiply the whole number with the denominator, and the answer that we get, we add it to the numerator. So you multiply the whole number, which is 10, with the denominator, which is 10, and then the answer that we get, you add it to the numerator. Okay, I'll just move and see. Okay, Praise, yes, it's very interesting, Lutando, you are right. Praise got it right. Butle got it right, well done. Oratile, you know what I love? I love that you showed me the method. So you say 2 over 2 plus 2 over 2 plus 1 over 2. Thank you so much. It's right. Oh, Sedi, you missed to add. Okay, use that other method. You say 2 plus 2, and then you say it is 4, which is correct. You forgot to add the numerator, which was plus 1. So then you say 4 over 2 plus 1 over 2. Nesedi. Okay, Zeketelo 5 over 2, you are right. Audrey, well done, 5 over 2. I saw it there. Okay, Ria, you forgot to, okay, you multiplied the whole number with, okay, now you're on the second one, Ria. I'm answering you for the second one. You say 10 times 10, you got 100. You forgot to add the numerator, Ria. So can I see the answer where you added the numerator? You forgot to add the numerator for me. Okay, Praise, you are right. Yes. No. Okay, the first one is right, but it's the denominator. The denominator is beating you up. Okay, so it's over what? I'm not going to tell you the answer. I want you to correct it. Numerator 103, you are right. Denominator, write for me the right denominator. I won't tell you the answer, Praise. I want to see the right answer. Okay, Amanda. Okay, you redo it for me, please, my dear. Okay, Kaylin, you're answering for that one. It was right. Connor, you are right. Connor, you are right. Grace, well done. Butle, you are right. Yes, Sedi, yes, thank you that you corrected yourself. You are right now. Thank you for answering. Naledi, you forgot to put something. Yes, okay, Praise. I can see that. Give me the denominator. Yes, and then the denominator, Praise. Yeah, I see you say 10 times 10 equals to 100 plus 3 equals to 1 over 3. Give me the denominator now. I want the denominator. Lutando, you are right for that one. The first one, yes. And then Ria, my denominator is not right. Oh, it's right, it's right. Well done, Ria. Yes, no, it's fine. 1 over 3 over 10. You are right. Tafika, give me the denominator. 1 over 3 over what? And then Zeketelo. Okay, Lutando, you are right. Sedi, you are right. You're getting it. Well done, Praise. Finally, she got it right. No, it's okay, Praise. No need for you to apologize. It's okay. Kaylin, you are right. Well done. Oh, you guys are good. Okay, Anonymous, double check for me. Okay, all right. Amanda, I will re-explain now. The denominator is 10. You are right, Praise. Okay. All right. So on this one, you will then say, we take the whole number and multiply it with the denominator. So we're going to say 10 multiplied by 10, we get 100. And then we say 100 plus 3 equals to 103 over, the answer is here, equals to 103 over 10. So you see the denominator does not change. It doesn't. Whatever method that you use, the denominator does not change. For the sake of time, I'm going to project these ones. And then you do them tomorrow. If you can be here by 11:15, I'll be here. And then I'll check your answers. So please take a scribbler or do a screenshot. And then screenshot number C. You work it out for me tomorrow. Maybe before you can write the answers. And then I'll tell you if it is right. Okay, another activity, because I said on your platinum, remember, we don't get these ones. Another activity, just copy these ones. Now we are converting from improper fraction to a mixed number. So remember, we said you say how many times does 6 go into 15. I think with this one it's easier. Or 15 divided by 6. And then, so 6 goes into 15 two times, remainder 3 over 6. Still, the denominator does not change. The denominator does not change, grade 5. Okay, and then you can copy this one. Still, if you see it as an improper fraction, it means that you must change it to a mixed number. So how many times does 10 go into 22? The answer that you get, you write the whole, and then the remainder becomes your fraction. It becomes your fraction. Okay. And then the last one, oh, all right. So if you, okay, I saw most of you wrote the right answers, and I hope you took screenshots or you wrote it down. Tomorrow, please, quarter to 11 if you can. I'm here. Any questions that you ask, I will answer you. Okay, some other people won't see them because I won't publish them, also for your security. So be here quarter to 11, and then we go over whatever that you didn't understand after you had practiced it. And then we can move on to tomorrow's lesson. So a proper fraction. So now this is a summary. A proper fraction has a value of less than 1. So if the numerator is smaller than the denominator, the value is less than 1. And then an improper fraction always makes a mixed number. And the mixed number always makes an improper fraction. If you get those two, I'm telling you, and a mixed number, it makes an improper fraction. And then improper fraction, it makes a mixed number. And then proper fraction, it does not make anything because it is less than 1. And then you're going to get it right. And then tomorrow we are finishing with fractions. Can you guys please also have some paper and pen? We're going to look at fractions of a whole, and we're also going to look at problem solving with fractions. So tomorrow be on time so that you don't feel like I'm moving too fast because maybe you were late. I also appreciate the effort of you joining. Maybe sometimes it was the link that was giving you problems and then you only managed to join later. So tomorrow, let's just be on time, and then yes, Tafika, you were right. Okay, remember I said when I'm explaining, I can't see. Amanda, you ended up getting it right. Well done. I want those donuts. I think you promised some donuts. Lunga, well done. You got it right. Amanda promised some donuts for us, guys. So tomorrow, Amanda want those donuts. Oradile, you also got it right. Okay, I think Connor was doing the second one. Okay. Okay, yes. But yeah, but you did well, praise. Please don't be too hard on yourself. Amanda, ne? Oh, but you make my day. Yes, I want my donuts. Okay, all right, that was number C. Okay, all right. Okay, guys, thank you so much for joining. Be on time tomorrow. Okay, I see, Grace, you were answering for that one, and it was right. Okay, thank you, Kia. You now understand. Thank you so much. I'm glad when you understand. Okay. All right, guys, I am out. Yo, we went over by 10 minutes, but it's okay. See you guys tomorrow. Be safe, wash your hands, stay at home. If you can, quarter to 11, be here so that you can ask me any questions and then that you're not left behind. I love you all. And yes, really, Amanda. Okay, all right. Amanda says she can't give me the donuts. Okay, it's fine. All right, bye, guys. See you tomorrow. I won't go because of Amanda with the jokes. All right, I'm out. Bye, Wutle. Okay, we